Welcome to students, a quick analysis of our lab from last week. I'm trying to simplify this down for you. There's many ways we can analyze this, but just getting at those few basics idea of reduction and oxidation. So here's a simple diagram. I chose to use copper sulfate as the one we're looking at. We did 3 different solutions. You don't have to do all of them. I said to include at least one chemical reaction in here. And so let me get the setup, and then I'll give you the reaction that you can use. You could have used any of the other 3 that we had. The battery ultimately is my 9-volt up here, is my source of electrons. So electrons are flowing from, and that's a separate chemical setup. Love to do more with that, maybe a little bit in physics, but that is a separate setup of different chemicals inside the battery to produce that source of electrons. So electrons are flowing from here. They're flowing through my solution, and they're flowing all the way up this direction to the anode. And so you have 2 different things that are going on. These electrons are being used to do something. So the electrons that are being used right here, they are finding the nearest thing that can be reduced. So a reduction means you're gaining electrons. Where does the word reduction come from? It is reducing positive charge. So right here, you saw the copper forming at the cathode because the copper is gaining electrons. The copper ions in solution are now gaining electrons, so you get solid copper. That's one reaction you need to look at. That's the reduction. Well, that's one thing that's happening here. The other side of it is that over on this side at the anode, those electrons are being used to do something else. And so in that case, what's over here is that the water is being oxidized. At the anode, you saw some bubbles being formed. As a result of this reaction. So the bubbles that are forming are happening because my water is being oxidized. Down here. So oxidation, you are losing electrons. That energy from the battery is being used to drive apart water. And so in this reaction, and this is you could put this equation down, it's a little oversimplification, but basically the power from that battery is being used to drive apart this into hydrogen ions and then oxygen gas. Yes, you get some more electrons as well, but that's, which is also, I've mentioned to some of you, could also put electrons that are happening. You get some loose electrons there as well. But the key thing is, at that anode, you're getting oxygen gas. Those are the bubbles that you were seeing forming at the anode. That happened in all 3 of the reactions. And the H+ ions that are forming, that's the same thing as an acid. So you had an indicator present to tell you that you were producing some acid. The color changed at the anode as you were moving it around because you were producing right there in that oxidation. Water is being driven apart, and you're getting H+ ions that are forming. So you saw both those things happening again. When you observe this, in all these cases, you saw solid metal forming right here, forming on the end of my carbon electrode on the cathode. And then on the anode, you saw bubbles being formed and a color change happening. If you tried sodium chloride, like table salt, it was a little bit different. And that's one, if you want to use that, feel free, but that's maybe a little bit extra to do on that. So that's how you could summarize this one. I think I got all the terms in there that I asked you to do. So if you have other questions after watching this, great, send them in. I'll post this on the channel, but please let me know if you have questions after watching this.